In this video, we'll be introducing the derivative. Our objectives will be to answer conceptual questions involving tangent lines and derivatives. We use limit definitions to find equations of tangent lines. We use limit definitions to evaluate derivatives at given points. We'll compute average and instantaneous rates of change from graphs and tables. We'll find functions from the limits of difference quotients. Your difference quotient, it was defined in pre-calculus. So let's go ahead and get started with this. Before we go too far, let's just say a derivative is the slope of a tangent line at a point. And let's take a look at this. We already had a video about this that was supplemental that is in the YouTube playlist. When we talked about limits, we talked about this idea of rotating the secant line between 2 points down the graph of the function f of x to obtain a tangent line of a point of interest. But let's go ahead and we'll do a rough sketch here of a function f of x that's curved. And we'll put a point on here that is going to be a f of a. And then I'll put another point over here. It's going to be b f of b. I'll do my best to draw a secant line through those 2 points. Then I'm going to pick a different color here, and we're going to bring this point down a little bit and make another secant line here. And we'll say that this here, we can call that x1. And we can call this point here x2, and we have x2, f of x2 here. We're gonna there we go. It's a lot harder for me to go downhill than uphill like that. And now I'm going to do my best to draw the tangent line here that just touches the curve at that point and has the same slope as the curve there. And it's something like that. So hopefully you can see that the slope that is the same for the line and the curve at that point. So let's see here. We want to also say that this distance here from x equals a, and we have f of a over here, that we want to call this distance between a and b. B is right here. I'll call that distance between A and B H, because we want B to be equal to A plus H. Okay, so as I mentioned before, this is my tangent line. And so let's take some notes here that are color-coded. Note the slope of the secant line that's green. m equals f of b minus f of a over b minus a. You should know that as your average rate of change formula from pre-calculus. And for the pink secant line, we have the slope is f of x2 minus f of a over x2 minus a. And because a is b is equal to a plus h, we can make a substitution here, and we can say that this is f of b minus f of a over b minus a is going to be, and then f of a plus h minus f of a over a plus h minus a is h. And so I'm going to take the limit as h goes to 0 of these, and this is going to be equal to my derivative at a. We'll talk about that definition in just a second. This is my slope of the tangent line at x equals a for right now. And we've got that substitution that we made right there. That's how we get that a plus h. So, all right, let's go ahead and recall that we have learned the concept of the limit. So based off of the graph above, how could we use that limit to derive the slope of the tangent line? So remember that m is equal to f of b minus f of a over b minus a. The slope of the tangent of the slope of the secant line is the average rate of change. Rate of change of f of x on the closed interval a b. That's from pre-calculus. So taking the limit as b approaches a, or equivalently as h goes to 0, where h is the distance between x equals a and x equals b. We obtain the following definition, the limit definition of the derivative. And we just made note of this earlier, but this is f prime of a. It's going to be equal to the limit as h goes to 0 of f of a plus h minus f of a divided by h. The limit definition of the derivative at a specific given point x equals a is what this particular definition is. We'll have another definition here. So let's go ahead and write that definition down again. Right here, a equals limit as h goes to 0, f of a plus h minus f of a over h. And I'm just going to, that note actually goes down here. This is the limit definition of the derivative at a specific given point x equals a. Wrote that too high up there, but I get rid of that now. All right, let's go ahead and let's look at a couple examples here. So before we do though, let's just state that typically a problem will say something like use the limit definition of the derivative something like that. When we're told that, we're going to use this definition here. So when we're not given a specific a value, then we're going to have f prime of x is equal to limit as h goes to 0 of f of x plus h minus f of x divided by h, and we'll do some of both of that. So let's go ahead and let's use the limit definition of the derivative here to find f prime of x. So we were not given a specific point, so we're going to use that definition right there, that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Let's go ahead and have a little aside here to make sure that we know how to find f of x plus h. That's going to be x plus h squared, which is x plus h times x plus h. And we're going to have to FOIL, which is going to give us x squared plus xh plus hx plus h squared is x squared plus 2xh plus h squared. So now that we have that, come back and make our substitution. X squared plus 2xh plus h squared minus x squared over h. The parts without h's are going to zero each other out. Limit as h goes to 0 goes out front. and this is 2xh plus h squared over h. And we can factor here. And cancel the h. And that's going to give us f prime of x equals limit as h goes to 0 of 2x plus h. Now we're going to be able to use direct substitution. Now that that discontinuity is gone. So this is going to be 2x plus 0. Notice when I make the substitution, the limit symbol goes away. All right. That's going to be that example. Now we're going to talk about finding f prime of x is the limit as h goes to 0 of f of x plus h minus f of x divided by h. So for an aside here, f of x plus h equals x plus h times x plus h times x plus h minus x plus h. Let's just write this. It's h cubed minus x plus h, x plus h, x plus h, x plus h minus x minus h. All right, so now we need to FOIL over here on the right. I'm going to leave this first one over here on the left. X squared plus 2xh plus h squared. We did that one earlier. So x minus h. Now I need x times x squared plus 2xh plus h squared plus another h times x squared plus 2xh plus h squared minus x minus h. It's going to be x cubed plus 2x squared h plus xh squared plus x squared h. Those are common. Plus 2xh squared. Those are common. Plus h cubed minus x minus h. So this is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed minus x minus h. So we're ready to find the derivative now. Limit as h goes to 0 of all this minus my original all over h. That's going to be limit as h goes to 0, x cubed plus 3x squared h plus 3xh squared plus h cubed minus x minus h minus x cubed plus x. That adds to 0 and that adds to 0. Limit as h goes to 0, 3x squared h plus 3xh squared plus h cubed minus h. And I'm just going to put each one over h this time. So that's going to give me limit as h goes to 0, 3x squared plus 3xh plus h squared minus 1. And when I let h go to 0, this is going to be 3x squared plus 3x times 0 plus 0 squared minus 1. This is f prime of x all the way down. 3x squared minus 1. All right, let's go ahead and take on this next one, which is going to be a little bit different because we're going to have a square root involved. Remember your techniques from difference quotients back in pre-calculus and how we needed to rationalize the numerator when we had a square root function. So f prime of x is equal to limit as h goes to 0 of f of x plus h minus f of x divided by h, where f of x plus h is equal to the square root of x plus h. And so that means that f prime of x is equal to limit as h goes to 0 of the square root of x plus h minus the square root of x over h. What do we do with square roots when we want them to go away, especially when we have a sum or difference of square roots like this? Well, we're going to have to use the conjugate. So we're going to have to multiply by the conjugate of the numerator here, x plus h plus the square root of x over the square root of x plus h plus the square root of x. Thought bubble here, why we're doing that is because a minus b times a plus b is equal to a squared minus b squared. And if either a or b or both have square roots in them, then squaring them is going to get rid of the square roots. So that's what's going on here. F prime of x is equal to limit as h goes to 0 of x plus h minus x using our formula that's right up here, divided by h times, and then it's square root x plus h plus root x. So that's going to go to 0. F prime of x is going to be limit as h goes to 0, h over h, root x plus h plus root x. And we're going to evaluate here 1 over root x plus root x. It's 1 over 2 root x. Right? Let's go ahead now and talk about an example of finding a derivative at a point. First, a definition: the derivative of a function at a point is the derivative of f at x equals a, which is denoted f prime of a, and is given by either of the two following limits, provided that the limits exist and that x equals a is in the domain of f. So we've talked about this second one already, and we've been using that. The textbook is going to usually use this one, and it might actually use a C. Because the textbook likes the letter C instead of the letter A. It's the same thing. It doesn't matter whether it's an A or a C. We're going to use an A in our notes. So let's go ahead and say if f prime of a exists, we say that f is differentiable a. So again, important note here, x equals a is a given value. If you are not given an x equals a value, you must find f prime of x in general. The function that defines the derivative, and that function would be f prime of x equals limit as h goes to 0 of f of x plus h minus f of x divided by h that we've been talking about. This is a function of x for f prime of x in general. All right. So now let's work an example of finding f prime of a. So let's compute f prime of 2 using the limit definition of the derivative. So let's start with that second definition, the one we've been using. F prime of a is equal to limit as h goes to 0 of f of a plus h minus f of a over h. We have been given a equals 2, since we've been told to find f prime of 2. So that means f prime of 2 equals limit as h approaches 0 of f of 2 plus h minus f of 2 over h. So let's find f of 2 plus h. Let's find f of 2. Times 2 plus h plus 1 is equal to root 4 plus 2h plus 1. F of 2 is going to be root 2 times 2 plus 1 is root 4 plus 1 is 2 plus 1 is 3. So now that I have those two values, we're ready to find f prime of 2. That's going to be equal to the limit as h goes to 0 of root 4 plus 2h plus 1 minus 3 over h. We're going to have to make this limit as h goes to 0, root 4 plus 2h minus 2. Now multiply by the conjugate. That's going to be limit as h goes to 0 of 4 plus 2h minus 4 over h times root 4 plus 2h plus 2. And so we're going to get limit as h goes to 0 of 2h over h times root 4 plus 2h plus 2. H's will cancel. We'll be left with 2 over root 4 is 2 plus 2 is 2 over 4 is 1/2. All right. So now that we've learned about a limit formula for the derivative, let's take a step back. What does the derivative represent? It represents the slope of the tangent line at a point, right? That's the first thing we said in the notes today. So let's just write that here and say we have the derivative of f of x at a specific x equals a is the slope of the tangent line to f of x at x equals a. That would be my answer to that question if I were asked that on a quiz or a test or something like that. All right. If we were asked to find the equation of that tangent line there, I'd need another piece of paper. Actually, I just need to give myself some more space here. This is because there was a part B to this. So let me just give myself a little bit more space here. Move some of this up so I can answer part B that I never answered. So f prime of 2 is the limit as h goes to 0, 4 plus h plus 1 minus 3 over h equals the limit h goes to 0 of root 4 plus 2h minus 2 over h. And we're going to multiply by the conjugate here, root 4 plus 2h plus 2, root 4 plus 2h plus 2. And this is all part A. It's going to give me f prime of 2, limit as h goes to 0, 4 plus 2h minus 4 over h times root 4 plus 2h plus 2 is limit as h goes to 0 of 2h over h times root 4 plus 2h plus 2. H's will cancel. That's going to give me 2 over root 4 plus 0 plus 2 is 2 over root 4 plus 2 is 2 over 2 plus 2 is 2 over 4 is 1/2. And I need that 1/2 to answer my question here about the slope of the tangent line. Now, hopefully you remember your point slope form of a line from pre-calculus. If not, I'm going to remind you of that formula, and then we're going to use the pieces parts here for it. So y minus y1 is equal to m times x minus x1. And we knew that we had the point right here that we found f of 2 was 3. So that implies that we have the point 2, 3 on the graph as our x1, y1 that we need for our point slope form. So that's going to be y minus 3 equals, an m was this derivative here, x minus 2. So y minus 3 equals 1/2 x minus 1. Y equals 1/2 x. When we add 3 to -1, we get 2. And that is the answer there to part B. This was part A up here. All right. Let's go ahead now and let's take a look here. The value of the derivative of a function at the point x equals a is the slope of the tangent line to the graph f of x at x equals a, which is what we just said is the answer up there. Thus the derivative can can give us information about the slope of the function f of x. So let's consider this graph. I'm going to try and draw something that looks kind of quadratic here. Goes up and turns. It's going to come back down over here like so. Okay. So going to have at this point over here, this point right here, we're going to have a positive slope. You see that the tangent line is going uphill. It's increasing at this line here, tangent to that vertex right there. Going to have zero slope. This is a key idea, that we're going to have zero slope when the function is at a maximum or a minimum point, and we're going to, if we were on this side of the graph over here, we would have a negative slope. That is, here the f prime of x would be less than 0. Here we would have f prime of x is equal to 0. And here we would have f prime of x is less than 0. All right. So a 0 value for the derivative is a special case. Like I just said, we're going to want to pay close attention to that. F of x is neither increasing nor decreasing when the derivative is 0. So a negative value for the derivative means that the function is decreasing, like our orange tangent line. So call this B. We'll call this point here A. We'll call this point here C. So f prime of B is negative. This is increasing, like our purple tangent line. And f prime of A is greater than 0. And just f prime of C here was equal to 0. That was our red tangent line. All right, the average rate of change. That's something we talked about in pre-calculus. In f on the interval a to a plus h, or a to b, is the slope of the corresponding secant line. Since it was given to us as a and a plus h, even though sometimes that's given to us as b, we'll use this to say that the slope of the secant line is f of a plus h minus f of a over h. If it were given to us as a to b, it would be f of b minus f of a over b minus a. But we want to keep using that h in here on purpose because that's a calculus concept. We're going to start calling h delta x here in a little bit. The instantaneous rate of change in f at x equals a is the slope of the corresponding tangent line. At a, f of a, provided the limit exists. The slope of the tangent line equals limit as h goes to 0 of f of a plus h minus f of a over h. So remember that when we're finding the slope of a tangent line, that requires the limit process here. So the slope of the tangent line is the derivative, because that's the definition of the derivative. Okay. Consider the function f of x equals x cubed plus 4x. Find the average rate of change of f of x on the intervals 0 to 4, 0 to 2, and 0 to 1. So first we need to find it on the interval from 0 to 4. So we need, let's just make a little chart here for myself, x, f of x. And so we need 0, 1, 2, and 4. So f of 0, 0 cubed plus 0 is 0. 1 cubed is 1. 1 plus 4 is 5. 2 cubed is 8, plus 4 times 2 is another 8. That gives me 16. And 4 cubed is, let's see, 16 times 4, 24, yeah, 64, plus another 16 is 80. Yes. Okay, so for the interval of 0 to 4, we have f of 4 minus f of 0 over 4 minus 0 is going to be 80 minus 0 over 4 is 80 over 4 is 20. On the interval from 0 to 2, we have f of 2 is going to be 16 minus 0 over 2 minus 0. 16 over 2 is 8. And on 0 to 1, we have f of 1 minus f of 0 over 1 minus 0 is 5 minus 0 over 1 minus 0. 5 over 1 is 5. And so we can just do that as many times as we need to get closer and closer and closer and closer to some value, like 0. So what are the equations of the corresponding secant lines? So let's go ahead and keep using that point 0, 0 for everything, and then we're going to use the other points. So if we have 0, 0, and then 480, and our slope we got was 20, then let's use 0, 0. It makes my life easier if that point's on the line, because that's my y-intercept. So y equals 20x will be my secant line. For the second one, we have 0, 0, and the point 216. and m is equal to 8 there. So again, we're going to do y equals mx plus b. Y equals mx plus b is 0. And now we have 0, 0, and I think it's 1, 5. Yes, it is. 1, 5, yes. And our m is 5. So y equals 5x. All right. So we could see how those slopes would be changing if we graph them all out. Let's now find the instantaneous rate of change at 0, 0 and the corresponding equation of the tangent line. So for C, we're going to have to find f prime of 0 is equal to limit as h goes to 0 of f of 0 plus h minus f of 0 over h. So f of h is going to be, let's see here, h cubed plus 4h minus, and that's going to be 0 over h and we're going to factor an h out here. We're going to do direct substitution. We'll say that our answer is 4. So that means that f prime of 0 is 4, and that's the slope of our tangent line at 0, 0. So using the point 0, 0, m equals 4, and we have the point 0, 0, and y equals 4x is the equation of my tangent line. Let's go ahead and say what trends do we notice for part D. As we get closer and closer as B gets closer and closer to A, M of secant line, or we could say as B approaches A, the slope of the secant line approaches the slope of the tangent line. Okay. So you could graph all that in something like Desmos or your graphing calculator, and you're going to actually see those secant lines move towards the tangent line. But that's it for these notes. So we'll come back next time and we will talk about the next topic, which will be finding the derivative here. So the derivative as a function. We talked about that a little bit this time, but we'll talk more about that next time. I'll see you for that next video.